So today we're doing the last part of motion, which adds wind and water currents. Okay. You know what? I'm going to make it so generally, I guess with most of the motion, I've been doing one box, 2 by 2. Okay, how do I label my box? Andrea?
At the top, rate times time equals distance.
Rate, good. Call this rate times time equals distance. And you're gonna get points for each of those, including the operation. Now, how am I going to differentiate the two things I'm comparing on the left outside of the boxes? Shaylin?
Downstream and upstream.
Well, it doesn't say downstream.
Oh, sorry. Wind. Well,
You could say wind and
then return.
I'm going to say with wind and against. Shh. What?
It's the same flight there and
Hold on. Shh.
flight there and flight.
Okay, so the question was, can we use flight there and back? The problem is that doesn't differentiate them enough. It says, an airplane flew for 4 hours with 15 mile per hour tailwind. So with wind and the return flight against the same wind took 5 hours. Now, I'm going to also draw it, and I want you to do the drawing. So, here's my drawing, right? What's happening with this plane? He's going there, and he's coming back. So, I'm drawing the picture this way, and I'm drawing the picture back. So, this is with wind, and I'm labeling as much information as I can. And this is against. Okay. Now, what else does it say? With wind took how many? Took what? Yeah.
4 hours.
4 hours. And against it took 5 hours. Okay. Notice that when I have it in the box, one of the things I saw somebody getting confused with is that they put against on top and wind on the bottom for the box. And in the diagram, they put wind on top and against on the bottom. So make sure you line it up the same. Notice it's wind and wind are both on top. And against are both on the bottom. Now, now I can kind of start filling these up. I want to talk about some words, okay? Some important words. Tailwind and headwind. What's happening when the wind hits your tail? You're behind. Arden. You're getting pushed forward. What happens? I'm recording. What happens when you are hitting a headwind, your face, and you're putting your face into the wind? Yes. You're getting pushed back. So it's minus speed. Okay, minus wind speed versus tailwind is plus wind speed. The same thing happens in the water. When I'm in the lazy river and I'm doing nothing, no speed, and I'm just hanging out there, and what does the water do? It pushes me. That's plus water speed, plus current, with the current. And when I'm walking against the water, it's slowing me down. It's minus water current. Okay, other words to know. Downstream and upstream. When they say downstream, are you getting pushed or are you going against? Is it pushing you faster or are you going against it and making you slower? Ethan.
You're getting pushed forward.
Right, downstream, it's pushing you. It's going to be faster, the wind, the current. It's going to make you faster. It's going to be plus. Going upstream, it's against, it's opposite. Now, if you your body does nothing, that's just the rate of your body. But you know, like when you are on an escalator, those flat escalators at the airport, if you do nothing, you're going to get pushed, right? That my rate is 0. But what happens on that flat escalator at the airport if I all of a sudden start walking and it's pushing me at the same time? You go so fast. So you've got the rate of your body and the rate of the machine, or the rate of the wind, or the rate of the current. Do you understand? So when they add wind or current, it's just another speed that's getting added to your rate. So now let's look at it. For the airplane okay, first let's do, what is our time? Because that we know. Shailene, what's our time?
With wind, your time is 4 hours.
Okay.
And against wind, your time is 5 hours.
5 hours. Now, what else do we know without even having to think based on my diagram? My diagram right here. Hershey? No, says nothing about rate there. What do I know from the diagram's picture? Zenzele? The distance is the same. Anytime we go there and back, it's the same. Now, my rate. Now, do we know the rate of the airplane? When the airplane is in the air, do we know its rate of the engine?
No.
So what do we call it? Just R, right? Both there and back. Now, how am I showing it with wind of 15 miles per hour tailwind? Miranda.
Plus 15.
Plus 15 goes for with wind. And how would I show against Arden?
Minus 15.
Good. Okay. So, Shaylin, is this clear? Yes. Moreno, clear? Michael? Who else was out yesterday? Ethan? Armine? Is everybody understanding so far? It's really knowing those words. So now, because these are the same, I can build my equation. I can do one of two things. I can just write out both equations. 4 times the quantity of R plus 15 equals D. Or R minus 15 equals times the quantity of R minus 15 times 5 equals D. Or I can just say, I can start calling this D1 and D2 and do something like this. D1 is equal to D2. And then substitute right in. 4 times R plus 15 equals 5 times R minus 15. Now notice the time that is greater, if it takes 5 hours, it means you're going against minus speed. And then I'm going like this. I'm distributing. Yes, Shaylin, what's your question?
Oh, instead of doing D1 and D2 in the boxes, I just wrote out 4 times the quantity of R plus 15. So I was asking if that's okay.
Equals D.
Right. Well, I didn't put equals D in the actual box. So do you want me to put that in the actual box?
Oh, you just put it all the way over, and then you just set them equal. That's fine, I guess. Sure. What do you think, Sophia?
Yes.
Okay.
You need only to understand.
5R
If they
minus
also,
75.
That's what you have to draw the picture. Yes, did you see what we talked yesterday? How you go? Yes?
Okay, and now we are doing, let's add 75. Add 75. This equals 135. And then I'm going to subtract 4R, and we are left with equals R. And now the one thing you must do, 135, is it miles? Is it hour? Is it miles? Is it miles per hour? This right here will tell me if you make sense of it. Andrea.
Since it's a rate, it's speed, so it's miles per hour.
Miles per hour. You can write it like this. Okay, or you can write MPH. Either way, it doesn't matter. You must write the units. If you don't, we're going to start taking a point because that's half of the knowledge of the story. Okay? Okay, yes.
I just wrote.
All right, so now we're doing number 10. I'm just reminding you. And how am I labeling? First of all, let's say it takes a small jet plane 4 hours less time than it takes a propeller-driven plane to travel from Glen Rock to Oakville. What am I comparing on the left? Not in the boxes outside, the labels. Annabella?
The jet plane and the propeller plane.
Okay, so we'll call it the jet. Whoops. Okay, I'll call it the jet and the propeller. Okay, and on top, how am I labeling that, Michael? Okay, now I'm going to draw my picture. It takes a small jet plane 4 hours less time than the propeller plane to travel from Glen Rock to Oakville. Okay, draw a picture. Here's Glen Rock. And we're going to draw a line that represents what? The propeller, right? Or the jet. And then I'm going to draw another one that represents the propeller. Aren't they going to the same place? Oh, and they're going to Oakville. Okay. Now, we also know a little bit about this. What do we know about the jet plane? Luca?
The rate is 637 kilometers per hour.
Okay, and what about the propeller? Yep.
273 kilometers per hour.
Okay, and then, okay, that's all they're giving me. Well, no, they said, okay, now I'm going to start labeling my box. Easiest thing to do is rate. So we know that the jet is 637 and that the rate is 273. Okay, what do I know about the distance? That's something else. That's very clear. The only thing that's like making us guess is the rate. Preston.
It's the same distance.
So I'm going to put D and D. Now, tell me about the rate. I mean the time. The time is the only thing that's making us guess, not the rate. Luca?
So, the jet, the time is T minus 4,
T minus 4.
and the propeller is T.
T. Did anybody do it any different? How'd you do it, Callie?
I did the jet was T and the propeller is T plus 4.
So you can do it either way. Remember, you can do it either way. I can say that the propeller took 4 more hours, but the jet is just, jet is just T. But so they both do the same amount of time. It's just who does more, who does less. You could have written it like this, T, and this is plus 4 hours. Does that make sense? So you wanted to do it like this. All right, so now I've really kind of got my 2 equations. 637, I can just do D1 equals D2, right? 637 times T minus 4 equals 273T, right? That's supposed to be a T. And now I'm just distributing 637, right? 637 times 4. I'm getting 637T minus 2548 equals 273T. Subtract 637T. Subtract 637T. Now, if you are doing this, negative 2548. If you are subtracting, make sure, and you don't have a calculator, please write it out properly with the bigger number on top, off on the side. Okay, and it's a negative. Divide by negative 364. Divide by negative 364. And we have t equals what?
7. 7.
11.
7.
Oh, it's the
Is 7. Now, t equals 7, and we're talking about hours. Okay, what do you mean? So now I got to go back to the story and make sure. Is that answering the question?
No.
So what do I have to do, Anush?
You have to plug into 7 into one of the equations.
Into either equation. It doesn't matter. So really, what we're saying is that t in this case is 7. And in the other case, the time is going to be 7 minus 4, so it would be 3. So I can do either 3t equals d. 273 times 7 equals the distance. 273 times 7 is 1,911, and we are talking kilometers, is equal to the distance. So the distance is 1,911 kilometers. Okay, questions? Yes.
Just 2 quick questions. The picture, do you want us to draw it for every problem? And then,
I want you to derive your equation from the picture.
okay.
Okay?
And then, do you want us to always write the time and equal signs by rate, time, and distance? Do you have-
Up top?
Yes.
Yes.
Okay.
You're getting points for every single piece. This. I want to see times, equals. Well, if it's you're adding it, I would want to see that. If it's quantity, you're getting a point for this.
Oh, so you want us to put it
This.
in the boxes also?
You're going to get your 2 equations. 1 point for solving.
So you want us to, not just at the top, but also in between, oh my gosh.
I want you to use the boxes.
All right.
Okay? Yeah.
Just in general, I'm pretty sure on the quiz tomorrow we're gonna have questions where we can use the box to solve the equation, but if we
I'm going to show you. Well, I'm not going to give you something that wouldn't require a box. I'm giving you something that requires a box because I want to see if you can use the boxes.
Okay.
I'm not quizzing you tomorrow. I want to see, Common Core, can you, A, draw a picture based on the story, B, organize your information, C, can you build equations from this graphic, okay? All right, so tonight we're adding more problems. You've pretty much done these. This is not really new to you. I want you still using the box. Now, eventually you can get off the box. You don't need to use the box all the time. But right now, like I said, I'm giving you this because I want to see, can you utilize the box? Can you create the design? Can you create the equations from organizing your information? So when I make my box in this type of situation, how many rows and columns am I making? Callie? 3 by 3. So I'm drawing my 3 by 3. Okay, how am I labeling this, please? Preston, top.
On the side,
Okay, on the side on the left.
nickels and dimes.
Nickels. Okay, up top.
Me, so.
Sure.
Total.
I do not call the first column total. Shaylin? Amount, or I use number sign. Either one, I don't care. You can use the number sign. Keep going, Shaylin.
Unit rate.
What's the symbol?
Dollar.
No, what operation symbol?
Time. Sorry.
Times
Unit rate.
the dollars, right? Or unit rate.
And then equals product.
Product. Okay. Next. Yes.
Then you'd start to fill it in. Or, well, you could call nickels N and dimes D.
Good. N and D. And what else can I fill in? Ryan, you.
You for nickels, you put 0.05. And
Okay.
for the dimes, you put 0.10.
Okay. And what am I putting for product? What am I putting for product, Ethan?
I believe 0.05N and 0.05. Sorry, 0.10D.
Well, we call that 5/100ths N, and what decimal, how do I say it properly?
1/10.
D. And okay, how do I fill in my last boxes? Let's go with somebody I haven't heard from. How about, okay, Hershey?
So under the number part, it's 13.
And what is the operation?
Addition.
Addition. And what is my last box? What am I labeling it as?
Equals.
Sum. Sum and product. Okay, and so what did you say on the first column?
It goes 13 for the bottom.
And the last one?
$1.
Okay. And now I've got two equations. And that would be Luca?
N plus D equals 13. And 5/100ths N plus 1/10 D equals 1.
5/100ths N plus D equals, what did we say, 13? And 5/100ths N plus 1/10 D equals, I really should use the little d, equals how much? $1?
Can you make that 5N plus 10D equals 100?
Why?
Because it's easier to solve without decimals.
Tell me mathematically why. What makes it me able to do that?
You can.
You can't just can. Mathematically, what am I doing? Shaylin.
Multiply C by 100.
I'm going to clear it because I'm going to multiply by 100.
Say that.
You said you can just do it.
And then I said, you can just, wait, you can, and then you didn't let me finish.
5n plus 10d equals 100. And now what am I doing to my other equation, Ryan?
You're multiplying it by -5.
By -5. I'm going to go by -10. I think it's easier. I get -10n, -10d, because it's just less multiplication that I got to think about, equals 130, -130. Now I get -5n equals -30. Divide by -5, divide by -5, and n equals 6. So if n is 6, how do I figure out my d? Okay, Ethan.
So you would substitute 6 into one of the original equations.
Which equation's easier?
The n plus d equals 13. You would get 6 plus d equals 13. You would subtract 6 from both sides. And you get d equals 7.
Okay. And so I would say nickels, I have 6 nickels and 7 dimes. Is everybody clear on how to use this? Yes, question. No, you can ask now.
I'm just still confused on why you.
Okay, now they did not use the box. Okay? When you use the box, you don't have to identify your unknowns like let n be the number of nickels. Does that make sense? Does that make sense?
Yeah.
Okay? But if you're not using a box, you have to identify your unknowns. Are you okay?
Oh yeah, I'm fine. I'm okay.
So do you understand? This is pretty much the same thing. This is a quantity. How many? 19 coins. We're going to do exactly the same thing. We're not doing this one right now. This one here, movie tickets, same thing. Okay, I'm making my box. What size box are you going to make? Huh? 3 by 3, right. So I make my box. Movie theater sells matinee tickets for $5 and regular admission for $6.50. Okay, what am I labeling on the left? What am I labeling them on the left? Luca?
It's going to be n and...
But what am I calling it on the left? Not what variable, what word? You need a word on the left. Matinee. Everybody, all the kids these days, nobody knows what matinee means. But back in yeah, so we're going to call it in English and in French, matinee. And what's the other word? Regular. Good. And up top, how am I labeling the top of my box? Shaylin? Amount or number?
Times unit rate.
Times, what's the unit rate?
Money, dollars.
Good. Equals product. Okay, what am I using for matinee? Preston.
M,
What am I using for regular?
R,
R. Price of the matinee?
5.
5. So I move all the way over, it's 5M. This one is,
6.50.
this becomes 6.5R. Okay, what's the next one? Someone other than these 3. 4. How about Veronica?
Under the amount column, you put 195.
195, because I'm buying 195 total number of tickets, quantity.
Would you label it sum?
Yes, and I would label it sum, and it would be plus and equals. Thank you. And then what am I putting in the last box on the other side, Annabella?
1,110.
Do you guys understand how to do these?
Yeah.
2 equations. One's here, one's here. Okay, can I move on a little bit?
We can solve this.
Moreno, you feeling good? Okay. How about you, Michael? All the people that missed yesterday? I'm not going to finish this because I want to show you one more thing. Now, why don't I use X and Y?
You don't know which one's right?
I want to make sure that when I get my M, I'm talking about a matinee so I don't mess it up. Okay, now, one thing I want you to look at is like in the homework tonight. One thing I want you to see for the homework is want you to notice the difference. Okay, so let's look at, you've got, can you guys see that? Is it big enough? Yes or no?
Yes.
Okay, you've got different kinds. Tell me if I'm going to use the box or not. Right here. Number 5. I have a jar of dimes and quarters, contains $15.25. There are 103 coins in all. Am I using a box?
Yes.
Yes. Because it's quantity and dollar amount. Okay, what about number 6?
Yes.
I have quarters and nickels, contain $1.25, and there are 13 coins in all. Don't put it away yet. Number 7. A vending machine takes only nickels and dimes. There are 5 times as many dimes as nickels in the machine. The face value of the coins is $4.40. Am I using the box?
Yes.
No, because it's not just quantity and, do you understand? So in this case, I have to start defining my unknowns. I'm talking about N for nickels. Okay? I'm talking about D for dimes. And I'm going to do some translating. The first sentence says there's 5 times as many dimes as nickels. What do we have more of? Dimes equals what? 5N. That's sentence number 1. Now, the other one right here that says the face value of the coins is $4.40. Here's how you do that. Right? What's the value of a nickel?
10 cents.
A nickel?
It's 5 cents.
0 and 5/100 nickel. 5 cents times the number of nickels plus 10 cents times the number of dimes equals what face value? $4.40. So when they just give you a dollar amount, you're just always, if they're talking nickels and dimes, you got to put the money value before it. Does that make sense?
And then you multiply by.
And now you can solve it either through elimination or substitution. Are there any questions?
You'll be in here at lunch.
I'll be in here at lunch and after